Okay, so once again, good evening, everyone. So this time, this will be our second module, no, for this semester. So what we're going to discuss today is about the data mining fundamentals, processes, and applications, and of course, data mining ethics. Now, if you have some questions related to the topic, or do you have something to add, or you have some comments, suggestions, or additional inputs, everybody are requested to post your question in our chat box. So right after the presentation, maybe our presenter could able to answer all your query, or I'll just simply read all what you wanted to share with your classmates related to the topic or to the subject matter. Okay, so once again, good evening, everyone. So this time our topic is data mining fundamentals. Now today, we are generating data more than ever before. Now, over the last 2 years, 90% of the data in the world was generated. So this data alone does not make any sense unless it's identified to be related in some pattern. So data mining is the process of discovering these patterns among the data and is therefore also known as knowledge discovery from data. So again, we defined last meeting data mining, that is the extraction of explicit, previously unknown, and potentially useful information from data. So idea is to build a computer programs that sift through database or databases automatically, seeking regularities or patterns, and strong patterns, if found, will likely generalize to make accurate predictions on future data. Machine learning provides the technical basis for data mining, and it is used to extract information from the raw data in databases. So to give us more details about the topic, let us all welcome Sir Kenneth. Go ahead, sir.
Hello everyone. Good evening. Today we're going to discuss about data mining fundamentals. So first, let's define what is data mining. So data mining is the process of analyzing massive volumes of data to discover business intelligence that can help companies to solve problems, mitigate risks, and seize new opportunities. This branch of data science derives its name from the similarities between the process of searching through large data sets for valuable information and the process of mining a mountain for precious metals, stones, and ore. Both processes require sifting through tremendous amounts of raw material to find hidden value. Data mining can answer business questions that were traditionally impossible to answer because they were too time-consuming to resolve manually. Using powerful computers and algorithms to execute a range of statistical techniques that analyze data in different ways, users can identify patterns, trends, and relationships they might otherwise miss. They can then apply these findings to predict what is likely to happen in the future and take action to influence business outcomes. So, how data mining works? Any data mining project must start by establishing the business questions you are trying to answer. Without a clear focus on a meaningful business outcome, you could find yourself poring over the same set of data over and over without turning up any useful information at all. Once you have clarity on the problem you are trying to solve, it's time to collect the right data to answer it. Usually by ingesting data from multiple sources into a central data lake or data warehouse, and preparing that data for analysis. Success in the later phases is dependent on what occurs in the earlier phases. Poor data quality will lead to poor results, which is why data miner must ensure the quality of the data they use as input for analysis. So there are 7 steps in the data mining process. So first is data cleaning. Teams need to first clean all processed data so it aligns with the industry standard. Dirty or incomplete data leads to poor insights and system failures that cost time and money. Engineers will remove all unclean data from the organization's acquired data. They use several different data pre-processing and cleaning methods depending on the resources of the business. For example, they may manually fill in missing values or utilize the mean of other data to fill in a probable value. Teams will also use binning methods to remove noisy data, identify outliers, and resolve any inconsistencies. Data integration. So this is the second step. So when data miners combine different data sets and sources to perform analysis, they refer to it as data integration. This is one of the top mining techniques to streamline the entire extract, transform, and load process. Many specialists perform additional data cleaning within different databases during this stage. This process This process ensures data quality, so it meets business requirements. Specialists will use data mining tools such as Microsoft SQL to integrate data. So the third step is data reduction for data quality. This standard process extracts relevant information for data analysis and pattern evaluation. Engineers take a small size of the data and still maintain its integrity during data reduction. Teams may use neural networks or other forms of machine learning during this mining process. Strategies may include dimensionality reduction, numerosity reduction, or data compression. In dimensionality reduction, engineers reduce the quantity of attributes in the analytics data. In numerosity reductions, team replace the original quantity of data with a smaller quantity of data. In data compression, engineers provide a compressed generalization of the collected data. The fourth step is data transformation. In this industry standard process, engineers transform data into an acceptable form to align with mining goals. They consolidate the preparation data to optimize data mining processes and make it easier to discern patterns in the final data sets. Data transformation encompasses data mapping and other data science techniques. Strategies include smoothing or eliminating noise from data. Other popular techniques include aggregation, normalization, and discretization. The fifth step is data mining. Organizations use data mining applications to extract useful trends and optimize knowledge discovery to generate business intelligence. This is only possible if a company takes full advantage of big data and collects the correct type of information. Engineers apply intelligent patterns to the available data before they extract it. They then represent all information as models. Specialists use clustering, classifications, or other modeling techniques to ensure accuracy. The sixth step is pattern evaluation. This is the stage where engineers stop working behind the scenes and bring insights into the real world. Specialists will pinpoint any useful patterns that can generate business knowledge. They will use their models, historical data, and real-time information to find out more about customers, employees, and sales. Teams will also summarize information, data, or use visualizations, data mining techniques to make it easier to understand. The seventh step is representing knowledge in data mining. Data analysts use a combination of data visualization, reports, and other mining tools to share the information with others. Before the data mining process even started, business leaders communicated data understanding goals and objectives, so engineers knew what to look for. Analysts can share their findings with these leaders in the form of reports. Most companies use dashboards or other business intelligence tools to generate reports and extract insights from internal data miners. Owners use these insights to optimize decision making, generate new business, eliminate waste, and create better advertising campaigns. So now let's proceed with examples of data mining applications. So first with marketing. So data mining is used to explore increasingly large databases to improve market segmentation by analyzing the relationships between parameters such as customers' age, gender, taste, and etc. It is possible to guess their behavior in order to direct personalized loyalty campaigns. Data mining in marketing also predicts which users are likely to subscribe from a service, what interests them based on their searches, or what a mailing list should include to achieve a higher response rate. Second is on retail. Supermarkets, for example, use joint purchasing patterns to identify product associations and decide how to place them in the aisles and on the shelves. Data mining also detects which offers are most valued by customer, or increase sales at the checkout queue. On banking, so they use data mining to better understand market risk. It is commonly applied to credit ratings and to intelligent anti-fraud systems to analyze transactions, card transactions, purchasing patterns, and customers' financial data. Data mining allows banks to learn more about our online preferences or habits to optimize the return on their marketing campaigns. Study of the performance of sales channels or manage regulatory compliance obligations. On medicine, data mining enables more accurate diagnostics. Having all of the patient's information, such as medical records, physical examinations, and treatment patterns, allows more effective treatments to be prescribed. It also enables more effective, efficient, and cost-effective management of health resources by identifying risk, predicting illnesses in a certain segments of the populations, or forecasting the length of hospital admissions. Detecting fraud and irregularities and strengthening ties with patients with an enhanced knowledge of their needs are also advantages of using data mining in medicine. In television and radio, there are networks that apply real-time data mining to ensure their online television and radio audiences. These systems collect and analyze on the fly anonymous information from channel views, broadcast, and programming. Data mining allows networks to make personalized recommendations to radio listeners and TV viewers, as well as get to know their interests and activities in real time and better understand their behavior. Networks also gain valuable knowledge for their advertisers who use this data to target their potential customers more accurately. All right, so for this topic, this is about the principles of data ethics. So again, let's define what is data ethics. So data ethics encompasses the moral obligation of gathering, protecting, and using personally identifiable information and how it affects individuals. Data ethics are of the utmost concern to analysts, data scientists, and information technology professionals. Anyone who handles data, however, must be well versed in its basic principles. For instance, your company may collect and store data about customers' journeys from the first time they submitted their email address on your website to the fifth time they purchased your product. If you're a digital marketer, you likely interact with this data daily. While you may not be the person responsible for implementing tracking code, managing a database, or writing and training a machine learning algorithm, understanding data ethics can allow you to catch any instance of unethical data collection, storage, or use. By doing so, you can protect your customers' safety and save your organizations from legal issue. So there are 5 principles of data ethics. So first is ownership. The first principle of data ethics is that an individual has ownership over their personal information, just as it's considered stealing to take an item that doesn't belong to you. It's unlawful and unethical to collect someone's personal data without their consent. Some common ways you can obtain consent are through signed written agreements, digital privacy policies that ask users to agree to a company's terms and conditions, and pop-ups with checkboxes that permits websites to track users' online behavior with cookies. Never assume a customer is okay with you collecting their data. Always ask for permission to avoid ethical and legal dilemmas. So second is transparency. In addition to owning their personal information, data subjects have a right to know how you plan to collect, store, and use it. When gathering data, exercise transparency. For instance, imagine your company has decided to implement an algorithm to personalize the website experience based on individuals' buying habits and site behavior. You should write a policy explaining that cookies are used to track users' behavior and that the data collected will be stored in a secured database, and train an algorithm that provides a personalized website experience. It's a user's right to have an access to this information so they can decide to accept your site's cookies or decline them. Withholding or lying about your company's methods or intentions is deception and both unlawful and unfair to your data subjects. Next is privacy. Another ethical responsibility that comes with that comes with handling data is ensuring data subjects' privacy. Even if a customer gives your company consent to collect, store, and analyze their personally identifier information, that doesn't mean they want it publicly available. PII is any information linked to an individual's identity. Some examples of PII include full name, birth date, address, phone number, social security card or social security number, credit card information, bank account number, and passport number. To protect individuals' privacy, ensure that you're storing data in a secure database so it doesn't end up in the wrong hands. Data security methods that help protect privacy include dual authentication, password protection, and file encryption. Next is intention. When discussing any branch of ethics, intentions matter. Before collecting data, ask yourself why you need it, what you'll gain from it, and what changes you'll be able to make after analysis. If your intention is to hurt others, profit from your subjects, witnesses, or any other malicious goal, it's not ethical to collect their data. When your intentions are good, for instance, collecting data to gain an understanding of women's healthcare experience, so you can create an app to address a pressing need. You should still assess your intentions behind the collection of each piece of data. Are there certain data points that don't apply to the problem at hand? For instance, is it necessary to ask if the participants struggle with their mental health? This data could be sensitive, so collecting it when it's unnecessary isn't ethical. Strive to collect the minimum viable information of data, so you're taking as little as possible from your subjects while making a difference. So next is the outcome. Even when intentions are good, the outcome of the data analysis can cause inadvertent harm to individuals or group of people. This is called the desperate impact, which is outlined in the Civil Rights Act as unlawful. Data science principles Harvard professor Latanya Sweeney provides an example of disparate impact. When Sweeney searched for her name online, an advertisement came up that read, Latanya Sweeney arrested. She had not been arrested, so this was strange. What names, if you search with them, come up with arrest ads? Sweeney asked in the course. What I found was that if your name was given more often to a black baby than to a white baby, your name was 80% more likely to get an ad saying you had been arrested. It's not clear from this example whether the desperate impact was intentional or a result of an intentional bias in an algorithm. Either way, it has a potential to do real damages that disproportionately impacts a specific group of people. Unfortunately, you can you can't know for certain the impact your data analysis will have until it's complete. By considering these questions beforehand, you can catch any potential occurrences of this disparate impact. So that ends my presentation. Any questions? Any?
Okay, so I think